Hello everyone and welcome back for a new video. This video I will talk about this video is kind of NSA inclusive video. So I will talk about two things from NSA CIA. We'll talk about Ghidra, which is a new tool released by NSA to disassemble malware and to analyze malware. And we'll look also at Stuxnet. And Stuxnet, if you don't know Stuxnet, it was very famous malware released in 2011, and it was used to attack Iran nuclear reactor and their own nuclear reactor to affect them and make them weak enough to not produce any weapons. Anyway, this video is a small video. It's a highlights video. It's a bit advanced. So if you are new to malware analysis, if you are also trying to build your career in malware analysis, I have included here a link to, it would be here in the annotation or in the description. It's a link to a webinar that I have created for helping people to learn malware analysis. The reason I created this webinar is because of there is not lots of people who talk about how to build your career in malware analysis. There's lots of professionals working in big companies, lots of people trying to reach that, and they go through really long loops, like working 3 years as a SOC analyst or taking lots of certificates or paying thousands of dollars. I think SANS exams like $1,600. It's just the exam, apart from the course itself. So it's really lots of people go into really long loops or trying to learn from resources online, and they get totally lost. So I try to make a kind of a guideline, a roadmap on how to learn malware analysis and be a really unique candidate if you're applying for a job, have a really good resume, or even in the webinar create your future resume in front of you so you know exactly what's your target, where to go. So anyway, this is a roadmap for you to learn malware analysis in 1 year. Check this webinar out. I have talked about it in the previous video, and I also talked about it in this video. Check it out if you haven't seen it yet. The link is here or in the description. And now let's get into the video. So today we'll talk about the Ghidra tool, and basically this is a small video. We will hopefully it will be 20-25 minutes. Anyway, this tool Ghidra is from my point of view, today we'll just talk about my point of view about it and how this tool looks like. The first interface is this interface where you do create a project. You click new project, you create non-shared project mostly, or shared project you have to have a server and so on. So if you want to cooperate, or you can create a new non-shared project. And guess what? You create the project. The idea here is to have a whole folder for all the analysis for different samples related to specific project. Let's say you want to analyze Stuxnet, so you have here the dropper, you have here the rootkits, you have here the main sample, you have other samples that have been collected and it's in a different form, in all the samples together into one folder. The idea of having a category is really good. However, I did that analysis on another laptop than this one that I'm recording in, and I tried to copy this folder that has all the project and didn't open. What he told me is that this project cannot be opened, and because this project is basically only created for that a user called Amr. Okay, my username here is Amr, but in this machine is something else, it's my first and last name. So now I can't open that project again, and that's a bit strange. Anyway, this here in Ghidra, the idea of having a non-shared project is a bit strange, and the restrictions behind it is also a bit strange. But you can do the analysis. You can right click and then go to export, and here it exported to Ghidra zip file, and also some other things. You can export it to XML, for example, and you can import that file again. The only problem, this is really good, but the only problem is that you have to all the time export. You have to have a plugin that export every 5 minutes, or every time you try to click Control Save, it export. Is not only it saves the project, because if anything happened to your machine, you can't open the project again because it's a non-shared project and your analysis has gone. So you have to always export it every single time. Anyway, you put the sample here. I took the Stuxnet robber. You can rename it. You can, or it's the name of the file, I don't remember. You double click or you drag it to this tool, which is the main code browser. This is the code browser. And you can see this kind of 90s style UI, which is good. The tool here is quite interesting. So it is quite different than IDA. I would say that it focuses more on the text view. If you go here to the functions and then to go to, let's say, to this function, you can see it's mainly in the text view. It has the ability to highlight stuff. It has the ability to write comments above or on the side. Let's say some comments on the side here if you want to, or here, I don't know if that's a comment. You can see, anyway. You are able to put here the comments. You have also here the decompiled code on the other side. And for a bigger screen than this one, you can actually, or if I decrease the font, you can actually see the decompiled code beside it, the assembly code. So you can know like what exactly is happening, like what's exactly this instruction. You can select some instruction and he selects the corresponding C code here. So this is really good. For people who like TextView, they are very happy. This is like people like me. I like TextView. People who like graph view, they can go to window, to function graph, and they can see the graph view and they can zoom in, zoom out. They can also like edit. Here's edit, I think. Yeah, and they can edit here and, you know, make things a bit bigger, smaller. Let's say here, make this a bit bigger, or go here, let's say, make the signs of operands a bit bigger, and it makes all these windows, the small windows, bigger. You can zoom in, zoom out, take a snapshot. You can do so many things. But you can see that it mainly doesn't really focus on the graph view. It's like an additional feature, but it's not the main feature. The main thing is that you have here the text view and the decompiled view beside it, and you both look at both at the same time, which is good for somebody like me, but it's not good for some people who get used to the graphs from an IDA. I would say that this tool has some pluses and some minuses compared to IDA Pro. The first big plus is they have undo button. I like undo, and IDA doesn't have it, but that's a small thing, right? The main thing, the main weakness they have is that they don't have they don't have any debugger. They don't have any debugging capability. It's a great tool that can disassemble anything, can disassemble most of the type of files. It can decompile them as well. IDA Pro can disassemble many of them, but only the full version, like the premium version that you have to purchase, is over 1,500 now, the license for one person. While in Hydra it's free, it's open source and can disassemble all files. However, IDA has debugging capability, which this tool doesn't have. And debugging capability is really important because if you don't have this in your mind while designing the application, guess what? You don't have a dedicated UI. You don't have this assembler able to read from a memory process and able to switch between disassembling the main file, disassembling the process that has been analyzed, and you know, like if there is, like, let's say, if a self-modifying code or a backer that decrypts the malware in the memory, he's able to understand this is a new decrypted code and able to separate that from, let's say here, the disassembled file. You terminate the debugging, you terminate the process, you stop the debugging, and it turns back to the disassembled file, and they're able to switch between debugging phase and disassembling static analysis phase. Unfortunately, you don't have that. Does it need this to be in their mind while they started designing the tool? I think yes. I don't know. I didn't read the code, so I don't know how this is easy to be plugged in and the whole UI works perfectly fine with adding a debugger. The tool works on Windows, Linux, Mac. It's really cross-platform because it's based on Java. However, not having a debugging capability, it's really a big weakness. Like if it has debugging capability, I can debug a Mac application on Mac. That is really, really good tool because the other option is that I have to use regardé, which is a little bit hard to use, or I have to buy, I think, a tool called Workflow or something like that, and I have to pay like $100. So this is really a big weakness. However, for the analysis, they are really good that they have a decompiler. It's less than it's weaker than the decompiler from IDA. You can feel that sometimes when you are renaming some stuff, the decompiler like refresh itself and starts to modify some locals and removing like do some optimization, and then it was like, why it has changed? Like I was renaming that variable, why the code has changed? Basically, it decompiled the code and optimized it, and then some locals has been removed and some things has been changed. So the decompiler is a bit glitching, a little bit glitching. Other this, let's say in function, like we will talk in 2 minutes about how the Stuxnet looks like, but here I just want to show you this code. Let's say here you are able to go to something like be header and change the data type of this to set it as, let's say for this one, you can go to set data type, and then choose data type, and then you can say it's a pointer to a specific structure, and then you can see here in the code that he's able to read from this variable, read the values that are in the structure. You can view all the structures here in data type manager. You can go here, go to the B header, and go to, let's say, image entity headers. You can see all the headers. This is like the image file header. This is the image optional header. As you can see up here, here's the image optional header. You can go to the image optional header and see all the values and their offsets here. So it's easy to use, and you can actually use that to use the B header to be able to point to specific item in the structure. So like you can set the B header local variable into specific structure that points to specific structure, and then you have the decompiler code able to view all of this, like as you see here, B file header dot size of optional headers, let's say. So he's able to identify that this code is trying to access this item inside that structure. This field is inside that structure. So that's really good. You can create more structures easily here. You can create more structures, and you are able to deal with the structures easily, and that's really, really a good add. The last thing I want to mention about this tool is that it also has, if you go to window, there is also something called script manager. And script manager, you have so many structures, so many scripts, so many plugins that is written here, mostly in Java, but I think we have some in Python. And you can actually use any of them. There's so many tools inside and so many useful scripts. And it looks like it's a group of scripts that they have created through different requests from different people. There is one really good tool I found. It's called Ghidra UI. Basically, you select some code like this one, and then you go to the script manager, you click on Ghidra UI script, and it can generate for you, if we make it a bit bigger, it's able to generate a Ghidra rule for you. And not only this, you're able to remove constants or parse from the code. Let's say I want to keep that number, but I want to remove that address because it may change from one compilation to another. So I want my Yara rule to be a bit more flexible. So I want to remove that address. And you can see here, somewhere here, yeah, he's able to remove this and put some question marks. This is like in Yara, the wildcard. So basically it skips the byte here. You can also remove others as well, and you can see here he put this question marks in return and so on. So it's really great to create Yara rule. You are able as well to compare two files, compare two functions or two files that are two different samples, compare them to each other and see the difference between them. It has some really interesting things. This was like my first impression about it. Really good tool, really promising. However, not having a debugger is really a big weakness, and not supporting debugging as an idea. We can plug as many debuggers, we can create other debuggers, but if you don't support the tool itself doesn't support debugging capability, it will be very hard to add all the UI and able to switch between them. It needs the people who actually develop the tool. So this is like my first impression. And my first project, I was basically like decided to start analyzing Stuxnet. I have already analyzed it 8 years ago. Yeah, I think 8 years until now. And I have wrote an article about it in Code Project. If you didn't see it, it's called Stuxnet Malware Analysis paper. And in this paper, I talked about all the analysis of different parts inside this malware, including the dropper, which I was analyzing with Ghidra and seeing how it looks like in Ghidra. And I was doing some parts of the analysis using the analysis that I have did before, using some online resources, trying to reanalyze it again for a course I'm doing in malware analysis. And I will just like go through some highlights of the code inside this dropper. This dropper is actually really interesting dropper. It's very complicated. I didn't finish the analysis of it yet, but I will show you some stuff inside that dropper. So let's get started. It starts here with the check system version. It's just a simple code. Let's see it in here. Just simple code, get the Windows version, check if it's a specific Windows version. If it's not, it just doesn't run. Anyway, inside the malware, as you see here, all these code sections, there is here the stop section, which includes another module, includes another BE header and another DLL that actually this dropper drops and loads. It doesn't drop it on the hard disk. It doesn't drop any file on the hard disk, but actually it has a very interesting way in loading this DLL into memory. First, it goes to this function, which is load stop section, and load stop section looks like this. It includes magic number, which is this value. It includes BE offset, the offset of that BE file or that DLL, the main malware DLL, which need to be loaded, and the size of that DLL. All of this part is basically encrypted. This is not encrypted. This is the value will be the first 4 bytes, but the remaining data will all be encrypted, and he has a decryption routine for it. He starts first with searching for this data structure. He reads his own BE header and tries to find that section, finding the stop section. So if you go here, he starts to go through all the BE header. He first try to read the main module, the image base, his own image base. He check for MZ header. If it is, he goes to the BE header. He check if the BE header is BE. It starts with BE, the first 2 letters. If it's BE header, then he starts to find the number of sections add the size of optional header to it, and then go to all these sections, and then loop through the section until he finds a section called .stop. If you are the first time to deal with bheader, I recommend you to read about bheader before you understand this part, because it's all about bheader is really lots of structures and they're all connected to each other. It starts with the signature PE, and then it goes to something called file header, which includes, as you see here, it includes the number of sections, which is in this case will be 1, 2, 3, 4, 5. It will be 5. And then there is something called optional header, and after the optional header there is some other information called data directory. After all of this, it starts the addresses, each section starts to have the header for each section. So he skipped all these headers by calculating the size of all headers. Well, not really calculating, there is a value called the size of optional header, and he adds this value to the start of the bheader, and he goes to all the section headers. Now you have each section header starts with the name of the section, and then this is like 8 bytes maximum, and then they have the virtual address, the size of the section, and the size of this section on the hard disk, on the file itself, the address to it on the file, and all of this information. He basically loops through all of these section headers, trying to find the section header called .stop. Once he finds .stop header, he takes the address, he takes the size, he checks that the start of that section is basically starts with this value, which we said here, we said earlier. If we looked back, it is the magic value that makes him sure that this is a correct stop header that includes the DLL that he wants to load. After that, after he locates that header, this function returns the address of that header, and then he goes into decrypting that section, decrypt all the bheader and all the data, and then he start to load that DLL into memory, and then he calls to a function number 15. He gets the address of a function with the function number 15, and he calls to that function. This is basically how the loader works, but how the setup actually happens, this is all the magic in the setup part. He does a very strange way to uninstall that malware. So rather than he's trying to just like open the BE file or drop it on the hard disk and then use load library to load it, he wants to use load library, but he doesn't want to drop the file on the hard disk. So how he can manage to do it? He hook all the functions, let's see it here in the analysis. So he hooked all of these APIs one by one. These APIs are all used by load library function to be able to open any file. So this is how, like, ZW open file, ZW let's say close the file, map view of section which shows this file in the memory or load this file in the memory. So basically he modify all of these APIs to force them, rather than they try to open a file from the hard disk, they open the malware from the memory from his own stop section. So it's the way of it is like load library still loads the file, but I'm actually manipulating load library to be able to load the file not from the hard disk but from memory through hooking all of these APIs. I know for you it can sound very, very complicated, very, very complex. I understand that. And this is like a very small video, so I don't want to go so much into details on how this malware actually works. I know for some people this is very advanced, for some others this is maybe understandable. I'll just show one last thing about this malware, which is a common technique that many malwares are using. And if you find it advanced, as I told you, this is an advanced video. If you are starting in malware analysis, just check my webinar. You will learn how to actually learn malware analysis step by step, and then at some point this malware will be more understandable to you. If you are just starting, this is a quite advanced video, I understand. The last thing I want to show to you before finishing that video is that this malware, when it tries to call to some APIs, let's say open file or map view file, or even like allocate memory, allocate an empty space in memory like virtual unlock, he doesn't directly have these APIs in his import table. Rather than he has these APIs in the import table, he actually load this. He gets the addresses of all these APIs dynamically, and he calls them when he need them. So he doesn't have. When you open the malware in a BE loader, you don't see all of these APIs he's using, but he's actually dynamically getting the addresses of these APIs and calling to them. We see here there is a function. I hope I can find it from here. The function called get APIs. And function get APIs, basically, this function gets all of these APIs. Let's say string compare, virtual query, virtual protect, get pros address, map view file, all of these APIs, all of these Windows commands or Windows functions. Rather than he have it in his import table, he gets them, and he has the name of these APIs here. If you see here, these names are all encrypted. So basically, he decrypts the name of the API, and then he uses an API called get pros address to be able to get the address of this API. If you go up here in the code of this one, you see he calls to get API from DLL. He has here the address of kernel 32 string, but in encrypted form, the name of the API, as we saw here, the name of the API encrypted, and here he basically decrypt the name of the module, decrypt the string kernel 32, or decrypt the string NTDLL, whatever the name of the library, and here he goes to decrypt the API name, which is let's say strcamp or virtual query or something like that, and then after that he uses get module handle, which gets the address of this library, and then he uses get pros address, which gets the address of the function in this library, and then he calls to this library, to this function later on inside the code. This is a very, very common technique used by so many malwares. Until today, it's still widely used as a way of hiding the name of the functions or the APIs that a specific malware is calling or using through the execution, through the program. And this is kind of not really an anti-debugging, but anti-reverse engineering. It's kind of, you don't know what's the malware this malware is doing before you're actually digging inside the code. It also helps to bypass heuristic antivirus techniques, because they try to look at the APIs that the malware is using or any B file is using, and then if you see some APIs that looks suspicious or looks like they are, let's say, some APIs related to keylogger, or some APIs related to scanning the name of the processes or things like that, he flagged this file. So this is a way to avoid being detected by antivirus programs, especially the heuristic ones. And yeah, that's all what I wanted to say. I hope you got something out of that video, and this is my impression on Ghidra tool. It was just like a quick testing for this tool and see if I can have more videos on it. If you got something out of this video, leave a comment and tell me what you think about it. If you want more videos about Stuxnet and you want to learn more and you want like a long video more detailed on how this loader works or how different parts of it works, just leave a comment. If you want more advanced videos like this one, more like highlights, tell me in the comments. Don't forget to check the webinar. The link is either here in the annotation up here or in the description if you didn't find it. See you in the next video, and tell me what you wish to see in the next video. Bye bye.